right, so, we need to look at the derivatives of tangent, cotangent, secant, and cosecant, because we have not done them yet. So, we're going to do tangent together. I'm going to have you guys do the other three, probably in groups, and then we'll look at them. So, tangent, to take the derivative of tangent, we can use the quotient rule. How could we use the quotient rule on that? Tangent is sine x over cosine x. So if we use the quotient rule for this, we would do low, so we got cosine, times the derivative of the high, which would be negative cosine x, minus high. You're right. No negative. Thank you.
The cosine is negative sign.
Correct.
Yeah.
Correct. Sorry, I messed stuff like that up too much. I'll offer extra credit for that. So high, derivative of the low, that one's going to be negative sign. All over the denominator squared, so cosine squared x. Now, if I simplify here, that is cosine squared x plus sine squared x over cosine squared x.
Oh, because the negatives cancel.
And that means 1. Okay? And 1 over cosine, what is 1 over cosine? Secant. So this can be written as secant squared x. Now, tangent is something you're going to see not nearly as often as sine and cosine, but you're going to see it fairly often. So like whenever you do your homework on this, you don't necessarily have to do this every time. We can commit to memory the fact that the derivative of tangent x is secant squared x. And if you have that memorized, then you never have to do what we just did again. And you can just, if you see something that asks you for the derivative of tangent, secant squared x is the answer. Okay? So we are going to do this for the other 3, all right, that we have not done yet. So let's split up and divide and conquer these. So let's have, hold on, split you guys. Let's see, Avery and Troy, you guys over, you guys do cotangent. You 6 right here, you guys do secant. Luke and Valeria, and you 4 over here, you guys do cosecant. Okay. So, it's basically the same as what we just did, except for you're starting with something different, right? Change it so that it's sines and cosines, and then do the derivative there. Yes, you guys, the U6 right here are secant. Yep. Okay? Alright, so, again, you don't have to do that every time. If you got it memorized, you can do that. I do like having this as a backup. One reason I'm making you guys do this right now, let's say you forget derivative of tangent, you could go through and do this and figure it out if you needed to during the test. So, secant, has somebody got theirs? Secant, you got it, Jeremy?
You, Jeremy? How confident are you in your answer?
Let's see. Looks pretty legible.
Buddy didn't hesitate
Okay.
to lay the blame somewhere else.
Okay. All right, so we got secant, which is 1 over cosine. So when we take the derivative here, you're going to do, Jeremy did not write this, but you'll do cosine times the derivative of the top. But what is the derivative of the top? 0, right? So right here he could have cosine times 0 minus the top, which is just 1, times the derivative of the bottom, which is negative sign, which ends up with a positive sine over cosine squared. And we were getting there pretty well, like you guys got there on your own for that. So what this means here with cosine squared is it's a cosine times cosine. So you can break it apart, and sine over cosine is tangent, and 1 over cosine is secant. So that is our derivative. So you don't have to have all that worked out, but we do need to make sure on your paper you've got written down that the derivative of secant x is tangent x secant x. Or the order doesn't matter. You can do secant first and then tangent for that. Yeah, well, no, it actually doesn't. It wouldn't be infinite loop. Because the next one you have to use a product rule on. Yeah. Alright, who's got one over here? Liam? Alright. This one is very similar to the one that Jeremy just did. We're just dealing with cosines or sines instead of cosines. So he has an address here. If you're interested in whatever that has to do. Lemon's address. Okay. For some reason, Lemon's address is involved. Okay. All right. Makes total sense. All right. Secant. Let's see. Wait a second. That one. Let's see. Where are we at?
It's up. You were there.
Where is it?
Right there.
This one?
Yeah. No.
Okay. So we got 1 over sine x right here. So we do denominator times the top, which is derivative of the top, which is 0, minus 1 times the derivative of the bottom, which is cosine. So we get negative cosine over sine squared in a very similar fashion to the way we did the last one. We'll do negative cosine x over sine x, and then we'll have a 1 over sine x. So this stuff is going to be cotangent. This stuff right here is cosecant. Okay? So again, you don't have to have all of that. It's not the love connection. The love connection is when you got one thing on the bottom and you're dividing both at the top. All of this is multiplied, so what we're doing is we're just kind of like breaking those apart as two fractions. So, now, we got negative cotangent x cosecant x. Now, you do not ever have to do any of those 4 problems again if you just memorize these here. It does have to be memorized because we do not get formulas. They will not give you the formulas for this. You will probably see at least one of these types of problems on a calculator inactive section somewhere, but probably not all of them. Sines and cosines, you'll see a lot of those. These, you're not going to see a ton, but you'll probably see at least one for that. So, you could make up a song to remember this. That would actually be good. The trig derivatives, that would be something good for us to know. So, let's look at a couple of problems like you're going to see in your homework. Okay? So, to take the derivative here, we are going to have to use the quotient rule for this. So, f prime of x would be low times the derivative of the high. Now, what do we just find the derivative of cosecant to be?
Negative cotangent x cosecant x.
Negative cotangent x cosecant x. Minus high cosecant x times the derivative of the low, which is just 1 here, all over x squared. So you have got, here you got negative x times cotangent x cosecant x minus cosecant x all over x squared. They might just leave the answer like that. You could factor out a cosecant, maybe a negative cosecant. So if you did that, you would have x cotangent x plus 1 over x squared. Yeah, it's the same. They might do something like this. They might do this, negative x cotangent x plus 1 over x squared times sine x. We might do that because cosecant is 1 over sine, so if you move cosecant back down to the bottom, it would be sine for that. So again, there's not really like a right way to leave your answer. Any of these would be fine. You know, this is okay. This would be okay. This would be okay. It just depends. Right here. This one. Or this one. This one. So this cosecant went away when we factored it out. So we just have a 1 there. Then this cosecant, I could also, like I could have written a step here. That negative cosecant x is like having negative 1 over sine x times x cotangent x plus 1 over x squared, right? Because this is just multiplied. So I could change that cosecant to 1 over sine x, and then that sine x goes to the bottom. I'm not saying that you've got to do that. Certainly, if it was free response, I would not. I'd leave it right here if it was free response. If it is multiple choice, you never know what they're going to do with their answers there. Okay, questions? All right, here's one more. Okay, this is a fun one. What am I going to have to use for this? What rules?
Product question.
I'm going to have to use... I actually don't think I used the... Well, you kind of... Yeah, never mind. Yeah, I was thinking power. Definitely use product and quotient for this. So you're taking the derivative. See, these two things are separated by a plus sign. So it's like you're taking the derivative of this separately from this. Now, I do it all at one time, but you're doing it separately. So when we take the derivative here, we've got 1 over x. So I can use quotient rule for that. So it would be low times the derivative of the high. What is the derivative of the high? 0. Actually, no. Do I have to use quotient rule for that? Back up. Do I have to? How else could I write this so I don't have to use quotient rule on that? X to the negative 1 plus e to the x, tangent x. Oh, that makes it a little bit easier, right? So now I can just use power rule. So I've got negative 1 x to the negative 2. But over here, I do have to use the product rule because I've got two separate pieces that are multiplied together, and both of them have x's. So, so I would do, I'm going to put some parentheses or bracket here so I'm keeping this separate. E to the x times the derivative of tangent x. What is that? Secant squared x. Well, right now we're doing e to the x times the derivative of tangent. But we now have to do tangent x times the derivative of e to the x. And what is that, Luke? e to the x there. So as far as how they write this, it just depends. I'm just going to send that back down to the bottom and just clean it up a little bit. E to the x secant squared x plus e to the x tangent x. I think they will probably just leave it like this. There's not anything glaringly obvious that could be changed. You could do something like common denominators, but then you're putting x squared over here. And I think they'll probably just leave it like this. Okay, questions? Alright, your assignment that you will have for this, it's not on that paper, so it should be on Canvas. Let me check and see. And then you can be getting out that free response and deciding which one you guys want to do on that. Let's see. Okay, not too many for this one. You've got, I'll write it bigger here so you can see it better. Page 154, you got 45 through 48, 50, 51, and 53. Okay, so 50, 51, yeah. Should be relatively straightforward on those. One of the good things about some of the trig is like it's so messy. There's not a lot of simplifying. So if you can just take the derivative, it's probably gonna be your answer. All right, questions. All right, do have that ready tomorrow. I might be here at the beginning of the class, and I might check it, or I may just have Miss Hendrick check it. So do have it there. All right, now let's look at our free response. Which one do you guys want to do? Let's see. Week 4. We have 15 minutes. We do not have time for that.
Number 2. Why number 2? I don't know. It's longer. Bigger.
If I were you, I'd probably pick 2. A is the harder part on number 1, but it's asking where those slopes are, the tangent lines are parallel. So if tangent lines are parallel, that means the slopes of the tangent lines are parallel. How do we find slope of a tangent line? Derivative. So you're going to take the derivative of both, you're going to set them equal to each other, and then you have a quadratic. And what I see students having most trouble with this is solving it. How do you solve a quadratic? Move everything to one side, factor and solve, or you could do quadratic formula if it will not factor. This one does factor, so, or you can still use quadratic formula if you want, but you won't have a calculator, so, if you have that one. So let's look at the second one. And part B is just tangent lines for those, so point, slope, write the equation of the tangent line for both of those. Y equals m times x minus x1 plus y1. Right, you don't have to simplify it. Sometimes my solutions are old, back when I didn't know as much. Let me look at my solutions real quick. No, I left them like that for those. Alright, so let's look at 2. Car is driving back and forth along a straight road. The distance that the car is from a given gas station is given by S of t equals 5 times t plus 1 times t minus 3 squared for t is greater than or equal to 0. Hold on. Hold on a second here. How do I do this one? Okay. All right. That'll work. All right. So, part of this is the meaning of this because A is not a calculus question. A is asking you for the S of 2. What do we do to find S of 2? Plug it in. So S of 2, you're just doing 5 times 2 plus 1 times 2 minus 3 squared. Technically, you don't have to simplify that. It is going to be easier to explain your meaning if you simplify it, right? And it's nothing too bad. So 5 times 3 times negative 1 squared, you're going to get 15. So, for this t equals 2, what does that mean? In context of car gas station scenario. Okay, so at 2 hours, okay, what does S of 2 equal in 15 tell us? 15, what about 15 miles?
Car's 15 miles away from
The car is 15 miles from the gas station. Okay, so we think about like our graph there. We got hours here, and we got miles here for our S of t, right? Whatever it looks like, S of t. All right, S prime of t. Now, first of all, S prime of t is asking us to find the derivative, so we're going to have to do the work for that, and we'll talk about what it means at the end. So let's just work on finding first S prime of t. But before we can do that, do we know how to do this problem? With that square right there? Like as it's written. We can't just use a product rule here because that is squared. So you are at the very least going to have to square that out. So you're going to have 5 times t plus 1, and then you're going to get t squared minus 6t plus 9. Now, it is up to you on how you want to approach this. Now you could use a product rule, or you could just multiply this whole thing out, and then you can just use the power rule. It really doesn't matter. I think on the key, I decided just to multiply the whole thing out. Is what I did. So it's up to you. If you do that, you got t cubed minus 6t squared plus 9t plus t squared minus 6t plus 9. So we're just distributing here. Notice I kept the 5 out front. And so that is t cubed minus 5t squared plus 3t plus 9, which will be 5t cubed minus 25t squared plus 15t plus 9. So this is still S of t. I have not taken a derivative yet. Oh, yes, 45. Thank you. Okay, so if you do it this way, you got more work up front, but then the derivative is very simple to take. So S prime of t, make sure you label it S prime of t, is going to be 15t squared minus 50t plus 15. And this question asks us about S prime of t of 2. So we would then need to plug in 2. Make sure you label that. Don't go to just plugging in 2. Label it S prime of 2. That tells the grader that you're plugging 2 into your equation. So 15 times 2 squared minus 50 times 2 plus 15. So 2 squared is 4. 4 times 15 is 60 minus 100 plus 15, which is negative 40 plus 15, so negative 25. Now, we gotta talk about what in the world that means. So S of t itself gave us position. What is S prime going to give us? The slope, which is changing y over changing x. What are we measuring y in? Miles. What are we measuring x in? Hours. So miles per hour, this is going to be our velocity. You want to say velocity, not speed, because we've got negative 25 right here. So you can't have a negative speed. But you can have a negative velocity. This means if you have a negative velocity, it means you're going like in the negative direction there. So we would say at 2 hours, the velocity of the car is negative 25 miles per hour. And since we're saying velocity, it's okay to say negative 25. Okay, we're not going to have time to do everything right here, but I want to give you the ideas for C and D. The key is up. Is there ever a time on the interval 0 to 4 at which the car reaches the gas station? Mathematically, using these equations, when is it going to reach the gas station? If you are at the gas station, what is your distance from the gas station? 0. So we were wanting to show that S of t equals 0. So for this, I don't have time to do the whole thing, but you'll do S of 0, you'll get a number. You'll do S of 4, you'll get a number. You will use intermediate value theorem to prove that it is the case. I'm pretty sure. Let me look at my key just real quick. Actually, I just solved it. Can you use intermediate value theorem? Or you can set the equation equal to, setting the equations equal to 0 is better. It's easier to solve. T plus 1 times t minus 3 squared. Set it equal to 0, solve it. And you're going to get t equals. You get t equals negative 1 and t equals 3, but it told you way up here that t is greater than 0, so you throw that out. Okay? So, how about, is there ever a time in which the car stops? It may not have even stopped at the gas station. We don't know. You could be at the gas station but not stopped. You could be like driving past the gas station. So if you have stopped, it's not your position that has to be 0, but your slope has to be 0. Your velocity has to be 0, right? Because if your velocity, which is S prime of t, equals 0, then you have stopped. So we would take our derivative this time, which is 15t squared minus 50t plus 15, and set that equal to 0. And I believe it will factor. If it will not, let me look at my key real quick. Yeah, it factors. And you'll actually get 2 answers that where it stops. So I don't have time to go through all the work for that, but you guys understand the principles of what's going to happen. The work is posted so that you can look at that and see. Okay, questions? All right.